some time to work out all the kinks. I hope you enjoy learning math this way. This is new to me as it is new to you, so I think it will help you. I think it'll help me do a much better job teaching this, and I think it'll help you do a much better job learning the material. As you can see, my contact information is on this page. If you need to get a hold of me, it's georgiemath@gmail.com. You can email me at any time that you want. My email address is also on the Gibraltar webpage. But feel free to get a hold of me at any time if you ever have any questions or comments or concerns. So hopefully you enjoy. Please bear with me once again. This is a new venture for me, so I hope it goes well, and I hope it goes well for you. And this is our first flipped lesson, so good luck. I hope you enjoy. Please remember, always ask questions if you ever have them. I'm here for you. My goal is to help you be as successful as you can. So let's get started. We're going to start chapter 1 here, and the title of the chapter is Linear Functions, linear meaning lines. So most of this is review. So I think you should have seen almost all of this section at one point or another. It's very important because we're going to use this information a lot this year and later on down the road. So it's important that we review first. It's also a nice little easy review section to start on at the beginning of the school year. So section 1 of chapter 1 is called Points and Lines. And this guy right here, René Descartes, he's kind of the founder of this linear functions, and the Cartesian plane. Cartesian and Descartes goes together, and you'll see more of that on the next slide. But the objective of this section, if you want to write this down, is to find the intersection of two lines and to find the length and the coordinates of the midpoint of a segment, all of which we have seen before. You should have seen the length formula, and you should have seen the midpoint formula before. So I think we'll be good to go with that. And let's get started. Here we go. Here's a Cartesian plane, and a couple things we should talk about is this point right here. I think most of you should know what that is. It's called the origin. Hopefully you can read my handwriting. It will get a little better as we do more with this. But what the ordered pair for the origin is 0, 0. So the x value is 0 and the y value is 0 as well. And we have over here, this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. We always use Roman numerals to describe the 4 quadrants. Once again, this is the Cartesian plane, and the name comes from the founding mathematician of this, Descartes. So Cartesian plane, Descartes. That is where it came from. Moving on. Here's another example of a Cartesian plane with a linear function in it. The equation of this is 2x minus 3y equals 12. And we just need to kind of go over a few things from this. And once you see on the screen, there's 3 points that I've listed. The 3 points are 6, 0, 3, -2, and 0, -4. Hopefully you can see those well. These points, all of these points lie on the line, and they are called solutions to the equation. Not only do they lie on the line, but they're solutions to the equation. So if I plugged in each of these 3 points back into my original equation, you would see that they would, both the left and the right side would say 12, which means that they are solutions. These next 2 points are very important. We're going to start over down here with this one down here, this 0, -4. 0, -4 is called the y intercept. And if you notice, what is the x value of the x-intercept? The x value is always 0. Very important. X-intercept, the y-intercept, always has a x value of 0. So put a big 0 here. X is always equal to 0. Next important point is 6, 0. 6, 0 is the x-intercept because it crosses the x-axis. So 6, 0 is called the x-intercept. And what do we notice about the y value of the x-intercept? The y value always equals 0. The y value always equals 0. So the x-intercept has a y value of 0, and the y-intercept has an x value of 0. So very important that we remember those qualities of the y-intercept and the x-intercept. Moving on, there are a couple different forms of linear equations that we're going to need to get used to. The first form is called the general form of an equation. And the general form of an equation is looks like this: ax plus by equals c. And using numbers to replace the variables a, b, and c, we're going to use 2, -3, and 6. So 2x minus 3y equals 6. Typically, we always put the x before the y. But I guess it wouldn't really matter, but usually the x comes before the y. So, and these numbers can be positives and negatives, so you could also have negative 6x little technical difficulties here. Negative 6x, let's see here, minus 3y. Equals -7. We could also have that. So that all depends on what the particular example that we see is, but you could use positives and negatives here. The second form of an equation that we need to talk about, and you should remember this pretty well, is the slope-intercept form of an equation, and that is y equals mx plus b, and you've seen this many times. And an example would be y equals 3x minus 6. And from many classes previous, you know that m stands for slope, and b stands for the y-intercept. X and y-intercepts come up often in pre-calc, so we definitely need to know about that. And we'll talk more about slope in the sections to come. But so for this equation, 3 is your slope, and -6 is your y-intercept. So very nice. So this line would have a slope of 3 and a y-intercept of -6, which means that it crosses the y-axis down 6 units. So this section is a little bit longer than a lot of them. There's a lot of different review things that we need to talk about. We need to talk about 3 different types of graphing of linear equations. There are 3 different styles of lines that could appear in your homework and on quizzes and tests. The first one is the equation of something similar to the equation of y equals 6. Y equals 6. So this equation is when it only has a y equals. So y only. There's no x value, it's just a y. So if you notice, I'm going to make I made an xy table here, and it says y equals 6. So in the y column, I put a bunch of 6s, because that's what it tells us. Y is always equal to 6. And for the x values, it really doesn't matter, because all we know is that for every x value, y still has to equal 6. So we're just going to put a couple numbers in here, and we'll use 0. We'll use 0. We'll use we'll use -2. we'll use 3, and we'll just say 5. Okay, and when we do an XY table, these are all ordered pairs. So we're just going to plot these ordered pairs on our table, our Cartesian plane. So we have the x value, we have the x-axis, we have the y-axis. We're going to plot these points. So 0, 6. Remember, 0 in the x direction, 0 right here, and 6 up would be right here. Okay. Our next point is negative 2, 6. So that's 2 to the left, 6 up. So we have 0, 0, 6. We have 2, 6. Our next order pair is 3, 6. So that's 3 to the right in the positive direction and 6 up in the positive direction. And our last point is 5, 6. 5, 6. So it's 5 to the right and 6 up. And there we have it. We have 4 points. Hopefully you can notice that forms a line. And what kind of line is that? It looks to me like it is a horizontal line. Okay, so anytime you have y only, y only in your equation is going to be a horizontal line. Once again, I apologize for the poor handwriting. It'll take a little bit of time getting used to this program, so bear with me. It will get better, I promise. So hopefully it gets a little easier for you. The second graph we're going to do is pretty much the same. It's just completely opposite. This time we only have x in our equation. So all we have is x only. So what does it mean when we have x only? What kind of line do we have? And if you notice, in our table, all the x values are the same. All the x values are negative 3. So it really shouldn't matter what we put in for our y's because x never changes. Okay, so I'm going to put some numbers in here. Let's do 0. Let's do negative 3. Let's do 4. And let's do 7. And once again, please do not forget that these are ordered pairs, xy values that go on our Cartesian plane. All right, so let's plot some of these. We have negative 3, 0. Negative 3, 0. So that's 3 to the left, 3 to the left, and 0 up and down. Okay, there's our first one. Then we have negative 3, negative 3. That's 3 left and 3 down. Negative 3, 4 is 3 to the left and 4 up. And then we have negative 3, 7, which is 3 to the left and 7 up. And as you can tell here, what kind of line does it form? It forms a vertical line through those points. And I forgot to mention this on the previous page. Please do not forget to draw arrowheads on your graphs, meaning that the line goes on forever. So back to the last one, I'm going to add arrowheads to that previous line that we drew. So as you can see, that when your equation is x only, remember x equals some number, it is a vertical line. Vertical meaning straight up and down. Hopefully that makes some sense. Okay, so that's type 2. First we had horizontal, type 2 is vertical, and next we are going to talk about when there are x and y's in your equation. Okay, and we're going to graph this using x and y intercepts. So going back to the few slides ago, we're going to talk about the x-intercept and the y-intercept. So first, and I have another xy table here, and you can tell that I put x equals 0, y equals 0. That's what the x and y intercepts. So the first one we're going to do is when x equals 0. We're going to do when x equals 0. So I'm going to take my equation, and I'm going to plug in 0 for x on the first one, and I'm going to leave y. And then what we're going to do now is we're going to solve for y, just using algebra 1. So 3 times 0 is 0, so that kind of goes away. And then we have negative 2y equals 6. Divide by negative 2, divide by negative 2. Negative 2's cancel out. Y is equal to 6 divided by negative 2, which is -3. So 0, -3 is one of my intercepts, and that happens to be the y-intercept because x is 0 for the y-intercept. The next problem we need to do is we're going to do completely the opposite. We're going to do the x-intercept. So now, for the x-intercept, you can tell that y is equal to 0. So I'm going to go back to my original equation, and we're going to do y equals 0. So 3 times x minus 2 times y, but y is now 0, and that equals 6. So 3x, -2 times 0 is 0, so that cancels from the equation, equals positive 6. Divide by 3 using algebra skills. 3 over 3 is 1, so x equals 2, 6 divided by 3. So my ordered pair over here, oops, a little bit of typo there, is not equal to 6, because we just figured it out that it was equal to 2. So x is equal to 2 when y is equal to 0. So now basically what we've done is we were able to graph this equation using just the x and y intercepts. So the last thing we need to do is just plot these 2 points, 0, -3. So 0 and 3 down. There is my first one. And then 2, 0, 2 to the right, 0 up and down. There's my x-intercept. And another mistake there. And the next thing we're going to do is we are going to, I'm not really sure how that happened, but continue on. We're going to graph these 2 points. I missed the 2 dots. Hopefully you'll do a little bit better job on your paper. So what you notice here is that when your equation has both x and y in it, notice we have x and we have y, we have a diagonal. We have a diagonal line. We have a diagonal line. So when it only has an x or a y, it is a vertical or horizontal. When it has both x and y, like this one does, it is called a diagonal line. Hopefully that is good for you. That it should still be a review, but hopefully that makes some sense. The main part of this section that I really want you to understand is being able to find the intersection of these two different diagonal lines, or vertical or horizontal. And there's many different methods to find these. One method that you learned at some point in Algebra 2 and Algebra 1, I believe, to do these is a method called substitution. A lot of people didn't have very good, didn't like that too much. Then we had linear combinations. Linear combinations. What else could we use to find intersection points? You could graph by hand. You could graph these by hand, and lastly, you could use your calculator. And for our purposes in pre-calc, we are always going to use our calculator, because it's the quickest method. It's the method that will lend to the fewest mistakes, and you can use your calculator on the ACT test and the MME test, so we might as well learn how to do that now. So we're going to work through an example of how to graph these problems on the calculator. What they're going to do is they're going to give you 2 equations in general form, typically, sometimes in standard form. But what you have to do, what you must do, okay, over here on steps to solve, the first step to solving these is you must solve for y. You must solve for y. Okay, so what we're going to do is we're going to work through these 2 equations, and we're going to get y by itself in each of them using our old algebra skills. So first thing I need to do is remove the 2x. So I'm going to subtract the 2x from both sides. 2x minus 2x is 0. Bring down the 5y, bring down my equal sign. You always want to bring down the x first. And then I'm going to bring down my positive 10. Then I'm going to divide by 5 to get my y by itself. Divide by 5. You have to divide everything by 5 when you do so. 5's cancel out. I'm left with y equals negative 2/5 x plus 10 divided by 5 is 2. So that one is good to go. Sounds perfect. Next, we're going to do the other equation. Same exact steps. We're going to subtract 3x from both sides. 3x's go away. I'm left with 4y equals negative 3x plus 12. And I cannot combine those because they're not like terms. They both don't have x's. And then last step is to divide by 4. And divide everything by 4. 4's go away. I'm left with y equals negative 3/4 x plus 12 divided by 4 is 3. And there we have it. We have our two equations. Okay, that is the first step on how to find the intersection points using the calculator. Second step is to plug into calc. And what we're going to do is we're going to go to the calculator and we are going to plug our two equations in. And what you're going to do first is you're going to hit y equals, the very top left button. And you're going to make sure all of these y buttons are blank. There's nothing in them. Okay, so first thing we're going to do is then type in this first equation here, negative 2/5 x. You have to remember, always need to put fractions in parentheses. Always. So negative 2/5, negative symbol, not the subtraction symbol, negative 2/5 x plus 2. There's our first equation. Then you can either hit enter or down the down arrow, and it'll put you into y2. And what we're going to do next is we're going to plug in the second equation. And the second equation is negative 3/4, so parentheses, negative 3 divided by 4. Close your parentheses, x plus 3. So what you notice is we have all of our equations in our graphing calculator, y equals. The next step is to hit graph. Okay. And if you notice, I'm going to change my settings. I'm going to go to zoom 6. And that will take you to the standard screen, the 10 up, 10 down, 10 right, and 10 left. So what you notice is that we do indeed have two lines and they have crossed. And it's kind of hard to tell just by looking at what exactly points they cross. We're going to let the calculator do the work for us. So the next step, in which I'll write these down in a second, but the next step is to go to, you have to hit second trace. And if you notice, there's a bunch of calculating things here that you can do. You can find the value, a 0, minimum, maximum. Intersect is one that we want. We want to find the intersection point. So we're going to go down to number 5. And we're going to hit enter. And the next step is easy. It should say first curve. And what you're going to do when you see first curve is you're going to hit enter 3 times. 1, 2, 3. And when you do that, it'll say intersection, and that tells you that you have your intersection point. So let's write this answer down. The answer is 2 point. Let's go to at least 2 decimal places. So we're going to write this answer down here. 2.86, I believe, was the first point, and we have 0.86. 0.86 is the y value of our intersection point. So 0.86 is our ordered pair. So please do not forget to put those in ordered pair format. Please do not write x equals y equals, put them in an ordered pair with parentheses, separated by a comma. I'll know that the first number is your x value and the second number is your y value. Okay. So after you've plugged your equations into your calculator, you're going to hit graph. And once you see that the two lines intersect, after you hit graph, you're going to hit second, and then you're going to hit trace. And then you're going to go down to number 5, which is intersection. And then you're going to hit enter 3 times. And that will give you your answer. So first you must solve for y. Then you must plug into your calculator, and you want to plug that into the y equals button. So we'll put y equals there. Then you want to hit the graph button, second trace, number 5, enter 3 times, and there you have it. You have your intersection point. 2.86 comma 0.86 would be very hard to read on the graph without using the intersection menu. So hopefully that's okay. You can ask questions about that tomorrow if you need to. There are 3 different types of graphs you'll see. We just did graph number 1 here. 2 diagonal lines will intersect at a single point. You may also have the case where you have a vertical line intersecting a horizontal line. And once again, though, it still intersects at 1 point, so it's still the case. The second one you may see is you may have 2 parallel lines where they never cross. And the thing you have to remember about 2 parallel lines is the slopes are equal. If you have 2 parallel lines, you know that their slopes have to be the same, so their m values must be equal. And then the third one over here, so this was number 2, the third one over here is a distinct case of when the lines are right on top of each other. If you notice, there is a red line underneath and a green dotted line on top. That is when you are graphing the same equation. It doesn't happen very often, but you will see some examples, and we'll probably be doing some in the homework, and I'll talk about more when we get to it. But those are the 3 types: 2 diagonals or vertical and horizontal. They'll intersect at 1 point. Parallel lines never intersect. There are 0 intersection points. It has no answers. And when they lie right on top of each other, if you notice, there's lots of intersection points, pretty much infinite amount. Everywhere you go, they cross each other. So there's tons and tons of different answers for that one. So that one has an infinite amount of answers. But we'll talk more about those later. Last 2 slides, I believe, and we're almost done. Okay, these should also be reviewed for you. We have the distance formula, which I have written out for you here. And AB stands for the distance from point A to B. And the equation is the square root of x2 minus x1 squared plus y2 minus y1 squared. It's a pretty simple equation to use. We're going to do an example here. The example says find the distance from points A, -1, 9, and B equal to 4, -3. So the distance from A to B equals square root of x2. So we have 2 x values. We have an x value here, and we have an x value here. It does not matter which one you use first as long as you stay the same. So I'm going to start with our second one since it says x2. So 4 minus x1, which is -1. We have to still keep that -1 there. So I'm going to put parentheses -1, close my parentheses, squared, plus y2. What's our y2? So we have 2 y values. Our y values are -3 and 9. So I'm going to start with the second one, which is -3, subtraction symbol, 9, parentheses, squared, and all of this is underneath the square root. So moving on, underneath it, I'm going to simplify the numbers that we have here, square root, parentheses, 4 minus a minus. When you have minus and minus, that turns into a plus. So 4 plus 1 is 5 squared plus, parentheses, -3 minus 9, -3 minus 9 more is -12 squared. Okay, moving on. We still have to simplify our work here. 5 squared is 25 plus 12, -12 squared, -12 times -12 is 144. 125 plus 144 is 169, and square root of 169 is, that's a perfect square, it equals to 13. So the distance from A to B equals 13 units. Well, I want you to be precise in your answers. I just don't want you to write 13. Write the distance from A to B equals 13 units. Okay, so hopefully that's review. It's a little bit easy to make mistakes with all the different sign changes, but hopefully that is You've seen that before, and you can work that pretty well. But please make sure you write down the distance formula. We'll be using that quite often this year, and it often appears on the ACT test. So when I know things appear on the ACT test a lot, I'll try to write ACT so you can remember to jot those down. You might even want to start an ACT notebook of different formulas and things so you can have that handy. So last but not least, we have the midpoint formula. Once again, we have a formula I've written in the green box. Once again, this is a, I don't know what's going on there, get rid of that. This is an ACT formula. Make sure that you have this for the ACT, very, very important. So the midpoint formula is, it's an ordered pair, so we have parentheses separated by a comma. You add your x's and divide by 2, and you add your y's and divide by 2. So basically, you're just taking the average of two numbers, the x's and the y's. So let's figure out the midpoint of these. So parentheses, divide by 2, comma, divide by 2. They're both plus signs because we're adding. Close my parentheses. And let's plug in our two numbers here that we need to plug in. So first thing we're going to do is add our x's together. So our x's are -3 and -4. So we're going to add -3 plus -4. And it does not matter what order you put those in because you're adding them together. And our y values are 2 and -6. So we're going to add those together. So 2 plus -6. So finishing up below, divide by 2, divide by 2. -3 plus -4 is -7. And -2 plus -6 is -4. So -7 halves plus -4 halves. We always have to reduce our fractions if we're able to do so. -7 over 2 cannot be reduced. -4 over 2, it reduces to -2. Another way to think about this is -3.5 comma -2. So if we're thinking about a Cartesian plane, this is just an ordered pair. We could go 3.5 to the left and -2 down, and that would be the midpoint of wherever our segment is. So it just kind of gives you an example of what a midpoint is. So if you wanted to draw out -3, 2, -4, 6, -6, put them on the line on the graph, then plug in your midpoint, you'll see that it's right on the middle of the segment. So I believe that is it. There is no more slides. The first one is over. I hope you enjoyed. Always remember though that you can always stop the recording. You can pause it. You can go back. This will be posted on YouTube pretty much every lesson. Remember, if you ever have any questions, please don't hesitate to ask. I hope this went well for you. I hope you could understand it. Sorry for my poor handwriting. It will get better, I promise. Thanks again, and I will see you tomorrow in class.